All right, guys, we're going to do more area problems today. This time we're going to be talking about the area of kites, rhombuses or rhombi, and trapezoids. So one thing to point out too, like specifically to rhombuses, a rhombus is a parallelogram, and so you could find the area of a rhombus, rectangle or square, by just using the area formula for a parallelogram, which is what you know for a rectangle. But there's another one that we can use for a rhombus, and it's unique to rhombus. I guess you could actually also use it for a square because a square is a rhombus, but you couldn't use it for a rectangle because a rectangle is not a rhombus or a parallelogram. So I just wanted to make that little fun fact. All right, and we're doing that on page 109. And then trapezoids and kites aren't even in the same family. So remembering like our quadrilateral family is kind of important here for area and like which formulas I can use and which ones I can't. All right, so turn the page to 109 right here. Let's start with the trapezoid first because he's kind of weird. So kind of like with our parallelograms and triangles, we're looking for that 90 because wherever I have a 90, I have a height. Okay, so my height is always at a 90. Always, always, always. But then, so height at a 90. What I need to do to find the area of a trapezoid is I need to then take that height, add up the two bases, which are always the parallel ones, and multiply both those bases. So bases, these are our parallel sides, always, always, okay? So again, in the Desmos that we did earlier, you know, you can show this lots of different ways. Like you can cut the trapezoid in half, and if you like flip the top down, what you get is a really long parallelogram where the top connected with the bottom, and that's why we're adding up the two bases to get the full base of like a really long parallelogram. And then we're multiplying by half the height because we cut that height in half. So that's kind of where the formula comes from. And let's open that up and try some of those. So right at the top here, I can see they are showing me my 90. And so here's my height of 6. And then I have my two parallel side bases. And so we just fill it all in. So area equals half the height, which is 6, times the sum of the bases, which is 10 plus 7. And so, I mean, I can take half the height. That's no biggie. That's 3. And then I want to add up what I have in parentheses, which is 17. And then 3 times 17 is 51 units squared for the area. I should also say, too, actually, I'll wait to the next one because maybe it'll click back in. We talked about something special with the trapezoid before, again, when we were doing our quadrilaterals. Alrighty, so anyways, here I see my 90, so here is my height. And then I have a base and a base. And so this time, unfortunately, I do not have my height labeled for me. However, I do have this 30, 60, 90 triangle right here, where the side opposite the 34 is the smallest side. And so the one across from 60, which is the one that I need, will be root 3 times as much. So we'll have that our height is 4 root 3. And then the two bases. So this base is just 5. But then the other base is a full 12. And so, again, I can take half of 4. That's fine. So 2 root 3. And then I'll add these up for 17. And then I can multiply the outside numbers. So I'll have 34 root 3 units squared for my area there. And so the thing that I was going to kind of point out to you over here is maybe this formula looks somewhat similar. Like I feel like before we did half the sum of the bases, to get this line called the median or mid-segment line. So that's kind of another way to think about this formula. Like really what you're doing to find the area of a trapezoid is you're kind of doing, so the half and the sum of the bases part is your median, and then you're timing that by your height. So that's another little fun formula for area of a trapezoid. All right, let's try another. So here I have a right trapezoid, doesn't matter, still a trapezoid. Here is the height, which is also the same as this. So like either height is good there. And then we have our two bases. So the ones touching your heights are the parallel sides, which one of them does not look marked. So that's kind of annoying. And we're going to have half the height, which I don't see here, but I do see a 6.5 over there. And then I do see that one of my bases is 9. It's just the other one that's the issue. And so like looking at this 30, 60, 90, oh, I do know though, like here I kind of have a rectangle. So like this other side here would be 9. It's just not all of it. Like I need this little portion right here to sort of add them together to get like the full base, kind of like I did on the last one. And so I notice that I have this 30, 60, 90, where the hypotenuse is 7. And so the smallest side, which is opposite the 30, will be half as much. So 7 over 2, or 3.5. Actually, let's just go with 3.5 since I do need to add it with the 9. And so that's going to be 12.5. And so I don't know that I actually want to take half of the 6.5 yet. I'm going to add my two bases. So that's going to be 21.5. Oh my word, I don't really want to take half of any of this. But I guess I just kind of have to. All right, half of 6.5 is going to be 3.25. And then we're going to multiply that by 21.5. Should have left it as a fraction. So 69.9. I don't know. Let me double check that. Calculator. I'm doing this in my head and it's not advised. 69.875 units squared. Last one, a little bit Easter egg problem. Oof. If a trapezoid has a height of 5, a base of 6, and an area of 48 units squared, find the other base. So I always love backwards problems where they tell me the area and I have to find stuff. So we take our formula and we just plug in everything we know. So like working backwards here, they told me the area was 48, so that goes in for A. Half is just half. They told me the height was 5. And they told me one base was 6, so like I can put that there, and then plus the other one that I do not know that I'm going to try to solve for. So like right now, that base is sort of buried. And I also kind of don't want to take half of 5. So I'm just going to start getting rid of stuff. To get rid of half, I should times by 2. If I do it on one side, I have to do it on the other. And so that is 96. And then the half's gone. I don't really want to divide that by 5. Like next I could divide by 5, but I know it's not going to go into 96 evenly. So I'm actually not. I'm just going to distribute it. Like normally I wouldn't distribute, I'd get rid of, but let's distribute. So I have 96 equals 30 plus 5b2. And then maybe that's a little easier. I mean, not really. I'm still going to have to divide by 5. So we'll subtract the 30 for 66. Then I'm going to have to divide the 5, which just isn't going to go nicely. But so 5 goes into 6 once and then into 15 3 times. And it's going to be 1 over 5 left, which is 0.2, I suppose. And that's the length of your other base. Okay, so our other formula that we're going to talk about today is actually the same for rhombuses and kites. And also, I should make a note that because a square is a rhombus, you could also use this formula for a square. And kind of the uniting factor between all of them, well, let me tell you the formula first. So the formula that I can use here is D1, which stands for like a diagonal, times D2, which is just the other diagonal. And so, and then we take half. So the uniting factor between a rhombus, a kite, and a square and their diagonals is that they're all perpendicular. So again, because I have that 90 thing going on, I can find the area using the 90 intersection. So this is diag 1 and diag 2. And because we're like multiplying, it doesn't matter the order that you multiply them in, obviously. So yeah, half diagonal 1 times diagonal 2, super fun formula, love it. Rhombus, kite, and square, you can use that. All right, so looking at this guy here, I can tell that I have a rhombus. I can see that one diagonal is a full 12, and then the second diagonal is a full 8. And so we're going to do area equals half the first one, which was 12, times the second one, which is 8. You can take half of whatever you want. I'm going to take half of 12 because it's larger. And then 6 times 8 is 48 units squared. Just that easy. Looking at the next one, I can see that I have a kite, and one diagonal of the kite is a full 10. And then the other diagonal of the kite here is actually 8, because if they're showing me this side is 4, the other side has to be 4. If you remember, in a kite, one of the diagonals was bisected, and I can clearly see that it was not this one, so it has to be the other one. And so if I want to find the area, we're going to do half D1, which was 10, times D2, which is 8. You can take half of whatever, so maybe I take half of 8 this time, because multiplying by 10 is easy. And so I get 40 units squared. And then kind of last picture one here, I can see that I have a rhombus. And so they're showing me that this diagonal has one side of 3, and so the other one also is, because in a parallelogram, which a rhombus is, the diagonals are bisected. And then this diagonal has no measure on it. However, they did tell me that the side length of the rhombus is 5, and because the diagonals intersect at a 90, you have a right triangle right here. So you can use the Pythagorean theorem to find the length of the missing side. And so my hypotenuse is 5, so I'm doing like 5 squared equals 3 squared plus I don't know squared, which 5 and 3 are a Pythagorean triple, or part of a Pythagorean triple. Like, I already know that this is going to be 4, but I mean, you get 25 equals 9 plus b squared, and then subtract for 16, and then square root it. So this is 4, and so is the other one, again, because it's bisected. So when I find the area here, the full diagonal is 8, and the other full diagonal is 6. And so you can take half of whatever you want. Maybe I'll take half of 8 for 4. And 4 times 6 is 24 units squared. Oh my gosh, I could actually find the perimeter of this rhombus as well. And that one, truly, because I could have done the Pythagorean theorem to figure out like this hypotenuse and then found the perimeter. I also could have done the Pythagorean theorem twice over here for like the long triangle and then the short triangle and found the perimeter of that as well. Oh, that would have been fun. I should have thought of that. Ah, well. If a kite has a diagonal of 6 and an area of 48 units squared, find the other diagonal. So we're just plugging stuff in, trying to figure out what we don't know. And since they told me that the area was 48, we'll put that in for A. Then we have half. One diagonal is 6, so you can put that in for D1, and then I do not know the other diagonal, D2. So I could get rid of the half, but I can also just take half of 6. So let's just do that, and it's 3. So we have 48 equals 3 times D2. And I just want to divide the 3 away, which is 16. So the other diagonal is 16. All right, good luck on this one, guys. I think this one's maybe slightly easier because there are less 30, 60, 90 craziness.